Okay, Tammy Carver doing a class from summer school. I have graduated kindergartners all the way to going into 7th grade. So it is a variety class. It also has diverse learners in it as well. Okay, so at the end of today's lesson, you will be able to identify arithmetic patterns through problem solving and using different operations to solve the same problem. You will demonstrate understanding by writing your explanation for solving the problem. Okay, but before we jump into word problems, because we are on summer break, and sometimes we forget the things we've learned about word problems, I'm going to do a video to remind you how to work out a word problem so that you know what information you're going to need to pull out of that, okay? So. Okay, so that's just a reminder of how to pick out information out of your word problems. Okay, so here we go. Here is our problem for today. So our problem is you're taking a 5-day trip to Disney World, and you thought you had carefully packed your suitcase, but when you got there, you only had 2 pairs of shorts and 3 shirts. Uh-oh. How many of you done that when you packed for a trip and you didn't quite pack enough clothes that you thought you had for each day, right? So your job to solve it, it says how many outfits can you make without repeating the same outfit? Okay? So, doesn't mean you can't repeat the same article of clothes, but the whole outfit cannot be the same. We assume an outfit equals one shirt and one pair of shorts. So that has to, each outfit has to have a pair of shorts and a shirt. Your job is to figure out how many outfits you can make with those articles of clothing. We have manipulatives in the back that you can use. You can use cubes, you can use a chart, you can figure it out. You're going to use it on paper, you're not going to tell me the answer. Yes, you have a question, Oliver?
Oh, we just cut up the
No, that's not how you solve it. It is Wednesday, and then tomorrow is the fourth day where you go on your field trip. So tomorrow, yes. Okay. I'm going to give kindergarten, my youngest group, I'm going to give you the pieces of clothing for you to manipulate and see how many outfits you can make out of it, okay? There are yours. I have another set of that in the back. If you need to use that, we've got cubes. You've got anything that you need to use to solve it, and go. You're going to do it individually, and then we will talk about it in groups after that. So, how would you solve it? Are you going to figure out how many outfits you can make? How many more can you make? You can draw on your page, if that helps, if you are a person that has to draw. Everybody needs to come up with a solution. How many outfits can you make? Be able to explain why you picked the strategy you did, so that somebody else could say, oh, I see. Would you make a different outfit? So you make these two, with the pink and blue, with red and green, can you make another outfit? A different one. What's you have a solution? Do you have a solution to the problem? Do you think is the solution? Okay. We have a couple people still working. Solve your problem first. Are you giving me a thumbs up then? You're gonna be able to explain how you got that to another person? Well, sure you do. You didn't just pull a number out of the air. You need to solve it. Okay, I'm gonna partner you up with different. You do, but I can make more combinations with it. And combinations is different than just counting. Okay. Quickly, when Tim gets back, we will get compared. I will pair you off because I want to change different ages because some of you are older and we'll use a different strategy than some of the younger ones. Before you start talking, you guys already corrected that because you know your group. But I'm also going to go over some rules to our discussion because group discussion is what, this? That? Oh, because sometimes you have a camera. I don't know. And it's not on. We're recording this lesson. No, I don't need the light. Because I don't need extra light for this. Well, maybe I'll show you later. It might not be charged. Okay. Tim is alright, Tim is back. So I am going to have so Dylan, I'm going to have you work with Jude. Okay. Brenton, I'm going to have you work with Tim. Brenton, I'm going to have you work with Joe. You guys are going to share. Do I have an odd number? I do have an odd number. I'm going to have you work with Joe. Actually, you know what? I'm not. Joe, I'm going to have you work with Kendra. Brendan, I'm going to have you work with Oliver and Riley. Did I tell you? Okay.
You have Chisholm.
I have Chisholm. Chisholm, I'm going to have you work with me and Nick. Okay, I'm going to have Chisholm, I'm going to have you work with Riley. Brendan, I'm going to have you work with Nick and Oliver. And then Joe, I'm going to have you work with Kendra. Now I want you guys to share your strategy of how you got the answer you got. But before you go, hold on. Hold on. We have good night. so we're just gonna go on about our business. So, I want you to explain your answer. I want each person to have a chance to hear. You need to listen to what the other person did to get their answer, okay? So you're going to take turns. I don't want you telling them they're wrong or they're right. I just want you to hear how they got the answer they got. So when one person is talking, you can say, hey, who wants to go first? Let that person finish explaining how they got their answer. Then it's your turn. There is more than one way to solve this problem, so be open to learning different ways to find the answer, okay? And then you need to be able to explain to your partner the steps you took and also be able to prove why your answer might be correct. If you get done after you explain and you want to say, well, I disagree, if you guys' answers are not the same, you can say it. I disagree, but you need to start with, I disagree with because. Okay? Not, I don't like your answer, or your answer's wrong, but I disagree with the strategy you used because. Okay? Or you can say, I agree with such and such because. This makes it so we're both thinking together. This makes it so you can think together, okay? So go ahead and move into your partners that I gave you. You guys are sitting up here up front. I'm going to let you guys explain your strategy. So just hold on. So one of you decides to talk through how they solved the problem and why they got the answer, and then you share yours. He is with Oliver and Brinley. Yeah, you three are together. You guys have about 4 minutes to finish discussing. See where, how you figure out the problem. But it's okay because she challenges you, right? That's a good thing. I know, but if you challenge your mind, it takes your mind and makes you think just a little bit differently, and that's a good thing. It doesn't have to be argument. I disagree because it's not personal, it's talking about the concept. We are not personally saying we disagree with the person, we're saying we disagree with the strategy. And that's okay. When you're done discussing, give me a thumbs up on your desk so I know that you're ready. So I've seen a couple solutions. Brenton, can you come up and share with me your strategy of how you solve the problem? Do you mind coming up and sharing?
Yes.
Okay.
Okay, so for my strategy, what I did was, for the first outfit, you'd use your, how will I like this?
Why didn't we keep that on the paper?
You'll have your blue shirt and your white shorts for the first outfit. try to make that shirt shorter. A brown shirt plus, I saw them as red, so your red shorts would then equal your second outfit. But for outfit 3, you really don't have any more shorts left, or do you? Take your white pair of shorts. Okay, please leave. Thank you. Your white shorts. And then you use your only pair of shirt, or your only shirt left, which would be your pink shirt. That would be a third outfit. But you see, I summed up to being able to making 5 outfits. Pretty crazy, right? First, you take your blue shirt again. That's a D. Blue shirt. Then you take your red shorts, which was used in your second outfit.
Oh dear.
Blue shirt plus red shorts. That could give you the 4th outfit. This is extremely long.
Okay.
For your 5th outfit, you take your brown shirt. Or not, yes, brown shirt. And then your white shorts. And that's your 5th outfit. So, let me just get rid of this real quick. If you were to use all of these outfits, which you have a total, why does this just keep appearing?
You gotta be careful not to put some more so it's doing weird stuff.
Total would be 5 fits. And so if you wanted to wear all of these, which this part's pretty obvious, you wear 1 outfit per day. Just make that look a little better. There you have it.
Okay. Thank you, Rick. Anything else to add?
No.
Okay, thank you very much. Anybody else have a different answer? Brindley, you want to come up and show how you solved the problem? Or do you agree with any of it that Brenton had? Do you agree?
I kind of agree with this part.
Uh-huh.
I get 6 outfits because you put your pink and your white together, your pink and your colored shorts together, which are the red ones, and then you put your blue and your red ones together, your blue and your white ones together, your brown and your white ones together, and your brown and your colored ones together. And then
Okay.
you would get 6 outfits.
So with your answer, what is he missing? that's different from what your strategy guys?
You use the pink shirt once,
Okay, so what would be the other outfit that needs to be added?
the pink and colored shorts.
Okay, so go ahead and add that. And what did you use on your paper? How did you work it out? You worked it out with what?
Clothing.
Pictures, right? Brenton, you worked yours out with what? Not pictures, what did you use?
I'm trying to think of what I used.
So what do you have on your paper? Do you have pictures?
Right.
You use words,
Just
right? Yeah, you use words. So he wrote his out with words. You wrote yours out with pictures. There you go, girl. It works. Good, there you go. That works. Yeah, so we're consistent. Awesome. Did anybody else figure it out a different way? We have one that drew pictures, we had one that used words. Jude? Come up here and try yours. But did you do it the same way?
No.
Okay, so you show me your way of getting it.
So what I did was just 2 times 3.
And how did you come up with 2 times 3?
Well, you have 2 t-shirts, I mean 3 t-shirts,
Uh-huh.
and then you got 2 shorts. But you could put these here, and then you would have 2 on each. If you each one. Twice. That's basically all I did.
So yours was, so write 2 times 3 on the board. Okay. Awesome. So you saw that you were going to end up using those shorts twice with each one of those. So you did 2 times 3. Awesome. Anybody else have a different answer? Chisholm? And then Dylan, I'll get you next, okay?
I actually
guess
didn't
I
do
would-
it too.
I guess I did last.
Okay, so you took what it was and said we're not going to wear the same. Why did you think only 2? Why?
Because you have 3 shorts and 2 pairs of pants, and if he's going on a 5-day trip and he didn't have enough, you could only use the pants with 2 shorts.
Okay, and what made you think that you could only use 1 shirt, 1 pant? What was your thought process? Like why, what stopped you from making more combinations?
Because if you don't have enough money to go to a laundromat, you can't wear more than multiple days.
I gotcha. So in your mind, let me make sure I'm hearing you. In your mind, you could not wear the same shirt with a different pair of shorts because you think it would be dirty. Fair enough. Anybody else have that same thought?
Nope.
No? Okay.
But what, like, you can wear your clothes once without them being completely dirty.
So we have a disagreement. I disagree. I think you can't. Okay. What was the question? What was the question of the problem?
How many pairs or outfits could you make?
Okay. Was there any stipulation on whether they were dirty or clean?
Well, my thought is if you wore them
Uh-huh.
and if you didn't have enough money to go to the laundromat because you were going to go to like an expensive place and do fun stuff and you didn't have enough because you want to save up, you could only wear it that many times.
Okay. So what if we said it didn't matter if, what if I said you could wear the shirt multiple times? You could wear the shirt more than once. Could you come up with more outfits? You wanna think about that? If you could wear the shirt more than once, you can't wear the shorts more than once, but you can wear the shirt more than once. Could you come up with more outfits?
No. Because if you can't wear the pants more than once, you can't wear the shorts.
Okay, you're right. Let me rephrase that. If you could wear it multiple times, you're right. I limited you. You can wear the shorts more than once, and you can wear the shorts more than once without washing. Could you come up with more outfits?
Yeah, but if you sweat a lot, it'll make the clothes stink.
Right. I see where you're taking this like a literal, and I appreciate that because that's what we're all about, is figuring out how we would solve that in real life. But let's say that it isn't an option to wash them, but you still gotta wear clothes the next day. Right? Because I've got 5 days. I'm in Orlando, and you probably are gonna sweat because Orlando's hot. So I've got 5 days. You've got me 2 outfits. What am I wearing the other 3 days? Because that's what the problem is I didn't pack enough clothes for me to wear a different outfit every day without repeating some of my pieces of clothing, right? Like that's my challenge. So I'm going to have to repeat without. You see what I'm saying? I know what you're thinking though. I like it. Good job. Thank you for sharing. I totally know what you're thinking. Thank you for putting it in a real situation and putting in your logic into it. All right, Dylan, show me what you did.
Okay.
Okay. First off, what did you use to come up with your answer?
2 plus 2. 2 plus 2. Oh wait. 2 plus 2. 2 plus 2 equals 6.
Okay, so you have 2 plus 2 plus 2.
But
Okay.
do this like this.
Uh-huh.
June helped me on this top, and he did 2
Uh-huh.
plus.
You're okay. I know what it is. Keep going. You're okay. Sometimes whiteboards are tricky to write on.
2 plus 2
Uh-huh.
equals 6, because 2 plus 2 equals 4, and 4 plus 2 equals 6.
Awesome. Thank you very much. So you used addition. Jude used multiplication. Did you have a question? Yes, you may. Yes, you may. Okay, so this leaves me. I love that you guys shared that. Tim, do you want to share yours?
I want to mine.
Okay. I'm share yours, and then I'll have Oliver share his.
Can I go after Oliver?
Sure.
I'm going to go after.
We'll see if we can have enough space on our whiteboard. It's getting kind of crowded. So.
Brenton told me that you can buy stuff in the park at Disneyland. So I came up with 5.
But did the problem tell you could buy stuff in the park at Disneyland? No. So you got to go with what you got in the problem, right? Part of problem solving is you got to use the information that's in the problem. Did you have a question? Yes. Oliver, what did you have? Oh, how did you solve it? So here's yours. Maybe it'd be easier if you just turn around and show it. We're running out of paper. Okay, so Oliver has the floor. So tell us what we're looking at here. Tell us how you solved it.
I solved it by 8 minus 2 would equal 6. So when you have 6 pairs of clothes, you need an extra pair of clothes on the ride home. So like where that's the first day outfit, that's the second day, that's the third, fourth, and the fifth.
how did you come up with 8?
Because 8 minus 2 would equal 6.
I know, but where did the number 8 come from?
Number 8, because I was no, see, if you have 6, you might be able to have 8 minus 2 equals 6.
Yeah, I understand that 8 minus 2 equals 6, but where in your mind did you come up with 8?
My mind.
Like what got you to 8?
Because 8 minus 2 equals 6.
It does, but what in the problem, how did you get an 8? What is the 8 representing? 8 what? Oh, okay, so you're counting days.
Yeah.
Okay, that's what I wanted to know. Okay, I see. All right.
2 or 2 days. And now if you wash one of these clothes, if you wash them all, we'll have enough to get home.
Yeah, if we add some more information, some more problem solving, right? So if we were in this situation, right, the problem doesn't give us the options of washing clothes or buying clothes. But if we were in this situation, those would probably be some things we also think about. I could go get some more clothes. Maybe, if it's in my budget. I could wash them. If
Well, then just buy the dirty clothes.
Well, yeah, well you could, yeah. But if you're Chisholm, you're not wearing the dirty clothes because you sweated in Orlando. See how everybody's solving this problem just a little bit differently.
How come my clothes so stinky? Who's gonna be smelling me on my car ride home?
Well, where are the others in the car unless you're by yourself? All right, thank you, Oliver. Okay, so I want to talk about what the kindergartners did real quick because they did the same thing. So you used what? What did you guys use? You used I gave you guys, yes, you guys both got 6. They used, instead of drawing, so this would be similar to those that used drawings. I already had them pre-made for them so they wouldn't have to focus so much on drawing their shorts and shirts, but they could manipulate it with visual. And they came up with, how many outfits did you guys come up with? 6, by rotating out the shorts and the shirt. Not worried about whether it's a dirty outfit or, well, honey, baby, there's not enough room on the screen for you to draw. That's why I keep. Okay, so I want to come back to this because really what I want you to see is a relationship. So Jude decided that when he looked at, and you guys did a good job, I'm glad you guys all had, and your reasonings were very, very good reasonings for the way you solved the problem. I'm glad you all took the time to think, so thank you. It's okay. Okay, so what I want you to get into is, this is an introduction. So some of you, I have varied ages, so some of you have already done multiplication, like Jude. Some of you will be introduced to multiplication this year. What I want you to understand is this 2 times 3 is exactly saying I've got 2 3s. It is the same. So if I say I'm going to have those 2 pairs of shorts and they're going to go with, each of them are going to be paired up with 3. So if we had a short here, and we had a t-shirt, a t-shirt, a t-shirt, we're pairing it, we're pairing it, we're pairing it. And we're pairing it, we're pairing it, and pairing it. And how many lines do I have? 1, 2, 3, 4, 5, 6. So I can add the 3 and the 3, and that gives me 6 outfits. Okay? Multiplication and addition are friends. The reason why we use multiplication is because we can then get it smaller. Especially when we're looking at a multiplication problem like,
I know.
if we say, what does that mean? What does that mean?
Those 2 8.
I put 8 first, so let's say it the other way. So if I put 8 first, what am I looking at?
8
8 twos. So that means I'm actually doing this. These are equal, but this is faster. If I know that I'm adding 8 twos, I can just write 8 times 2, and I know I'm adding 8 twos. 8 twos is how much? Well, 2 plus 2 is 4, plus 2 more is 6, plus 2 more, 8. I did not write 8 twos. You guys, you should have told me that's not 8 twos, that's only 4. Come on now. You guys are supposed to be helping me out. Okay, so we got 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2, 10, plus 2 more, plus 2 more, plus 2 more. And those of you that know multiplication, what is 8 times 2? 16. So math, adding, and multiplication are friends. There is a relationship. So when you're multiplying, you're really adding the same number a certain amount of times. It's like groups. So I can take, I've shown you that I can take multiplication and turn it into an addition problem. But can I always take an addition problem and turn it into a multiplication problem?
Yes.
I can?
Or no.
Can I turn 15 plus 2 into a multiplication problem?
Yeah.
15 plus 2? Am I grouping anything evenly? No, I can't. So it's a one-way relationship. Multiplication, you can break it back down to addition, but not necessarily can you take addition and break it down into multiplication. So I have another example that's similar to our problem, but a little different, with the same process that I am going to play for you. Let's see if I can get my computer back. Okay. That is not what I wanted to
So as some of you already know, I really enjoy eating a good avocado, which despite its appearance that it looks like a vegetable, but it's actually a fruit. And let's say that I eat 2 avocados per day, and I eat 2 avocados per day for 6 days. Now, there's a couple of ways that I can think about how many avocados did I eat. I could say, hey, I eat 2 a day, and I'm going to do that for 6 days. So I'm going to add 6 2's together. So it'll be 2 plus 2 plus 2 plus 2 plus 2 plus 2. I have 6 2's right over there, and then I can add them together. And you can say 2 plus 2 is 4, you add another 2, you get to 6, you add another 2, you get to 8, you add another 2, you get to 10, you get another 2, you get to 12. And that all is fine. But there's an easier way to express this repeated addition. One way is to view it as multiplication. Instead of just writing out 6 2's and adding them together, mathematicians have come up with a neater way of writing that. They'll say, okay, we're going to add up a bunch of 2's. How many 2's are we going to add up? We're going to have 6 of those 2's, and we need to come up with some type of a symbol for it. So we will use this X looking thing. And so 6 times 2 can be viewed as repeated addition in exactly this same way. So 6 times 2 would be equal to 12. And we could go the other way around. If someone were to ask you, what is 4 times 3? Pause this video and see if you can write it out as repeated addition, like we saw up here.
Okay, so how would we write that out? 4 times 3. Dylan? How would I write that out?
It's 7.
So the second,
The answer is
so the second number is what we're adding. The first number tells you how many of them. So how would I write that as an addition problem? Like they did with the 6 and the 2.
3 times 4.
Okay, how would I make it?
3 plus 4.
So this is telling me I'm adding how many 3's? How many 3's am I adding? say 3 plus
4,
3
3,
plus,
3, 3.
there you go, yes. So it's the same as adding 3 plus 3 plus 3 plus 3. It's the same as 4 times 3. Very good.
It's 12.
It is 12. You are correct.
Well, one way to interpret this is to say this is 4 threes. So we could say this is equal to 3 plus 3 plus 3 plus 3. And 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is equal to 12. You might be familiar with skip counting. You would say 3, 6, 9, 12. Just out of curiosity, what do you think 3 times 4 is going to be? Pause this video and try to represent it as repeated addition, and then see what.
Okay, so last time we had 4, we were adding 3s. This time we're adding 4s. What is going to be our answer, Nick? How are we going to? It is, but how do we write that in an addition problem instead of a multiplication?
4, 4, 4, 4.
How many 4s are we going to add? How many 4s are we going to add?
3.
3. So it's 4 plus.
3.
No. 4 plus 4 plus.
4.
There you go. Do I have 3 4s? Do I have 3 4s? 4 plus 4 plus 4. Right. So then we stop there. Very good. Nice job. From the younger classes. So that's awesome. I'm glad that you guys are catching on. You're going to be ahead. You're going to look like you already know multiplication and probably starting school.
I don't even know.
Oh, well, you will, Mr.
What you come up with? Well, we can interpret this as 3 4s, and so we could say this is going to be 4 plus 4 plus 4. And if we skip count 4s, we'd have 4, 8, 12. I was about to go to 16. 4, 8, 12. So this is going to be 12. So this is interesting. At least for this example, for these two examples, I got to the same thing. 4 times 3 got me the same result as 3 times 4. Interesting. I wonder if that's always true. But anyway, big picture from this video is that you can view multiplication as repeated addition.
Okay, so what I would like you to do is on your piece of paper, I want you to tell me how math and multiplication are related. You kind of just said it, but I would like you to tell me to make sure that you understand it as well. So I want you to write on your paper, written. Yep. Write out how math and addition are related. Or multiplication. Addition and multiplication. Yes, thank you for correcting me. Addition and multiplication are related.